Welcome to part 1 of Competency 13. For this competency, a teacher needs to understand theoretical probability. In this video, we will work with sample spaces and probability trees. Number 1, what is the complete sample space created by an experiment rolling an ordinary number cube? Well, they just mean dice, okay? So you have to know that there are, for any cube, okay, not necessarily, let's say, number cube. What they mean by number cube is, what do we do? Well, we have 6 faces, and each of those 6 faces would be numbered from 1 to 6. So we know, because of the word ordinary, they could also say standard. You would not have a 0, and we would not have positive negative. So obviously it would be B. And yes, you do work with probability in middle school, for in some cases, maybe a little in 6th grade, okay, which would be standard, and then definitely 7th grade, okay. However, at this point, not in, very rarely in 8th grade. It would be included maybe in questioning, but not something you would directly teach. But still, it is a middle school topic. All right, so let's look at number 2. A 5-sided figure is numbered 1 to 5 on each of its faces. If the figure is rolled twice, how many outcomes are in its sample space? Well, that means you have 5 totals for one and 5 totals for the other. Okay. And the point of this is that you understand, let's say you had a number tree. Okay. Well, or a probability tree, rather, I should say. You would have one tree for each of those. So you would have to multiply those together. And you know that the total outcomes for one row would be 5, and the total outcomes for the other would be 5. But in the end, you would have a tree that would have 25. So obviously, option D. If you're unfamiliar with this, please, maybe you want to like pause the video, go to one of those good ones that I've talked about online, on YouTube rather. There's lots of good places on YouTube. At the end of all my videos, I do have my favorite person for YouTube that I love using. So you may have yours, or you may have notes. Go refer to those before you move on. All right, so let's look at what we have. Right. So what we have next is we have permutations. That is what we'll do for number 3. However, I wanted to stop and let you know that this is available on this calculator, and that when we're talking about permutations, the first thing you need to understand is that order matters, okay? And N means total number of outcomes, okay? And that's why we kind of talked about the dice, or a number, any kind of a number cube, okay? Not necessarily the standard. You could have 1 to 5, of course, from number 2. And then you have your R. R is your desired possibility. So that's whatever's presented in the number problem. Okay, so let's move on and take a look at number 3. Number 3, an experiment requires drawing 3 cards from an average deck of 52 playing cards. If the cards are drawn without replacement, how many outcomes are in its sample space? Note, each event is when a card is drawn. Since each card is unique, the order of the cards drawn will matter, which means this is a basic permutation. Now, you may say, well, this is out of the scope of middle school. Actually, it isn't. Why isn't it? Well, first, let's use permutation, and then I'll show you exactly what this means. Okay, first, what you need to do is put in 52. Now we need to push the PRB button, okay? And that means we want number 1 Okay, so you can do one or enter either one. How many cards? See, here's our 52. It tells us. But we are only concerned with 3 cards. So we push 3 and enter. And out comes a possibility that we need to work with. Okay. Right. So, or a sample space that we're going to work with. Well, what does this mean when we're teaching our students? Well, this is important. You will teach this in middle school. It means that on the first draw, we had 52. On the second draw, we only had 51. On the third draw, there were 50 left. And these are activity questions, maybe, well, with cards, because that's very common, or maybe with smaller numbers. But this is absolutely what you're going to have to do with your students. So, what do we have? 52 times 51 times 50. Enter. Same value. That is what this permutation means. Okay, you're probably not going to have your students use this in the calculator, but as an educator, you do need to know what this is. Okay, so it isn't totally out of the scope of middle school teaching. Okay, and I'm mentioning that because I ran into a couple of study guides that said that. Okay, I've been a middle school teacher for many years, and I'm here to tell you this is going to come up. So please acknowledge that you know how to, in your brain, put it in the back saying, okay, I know what to do with the calculator. And I also know how to just explain it in very simple terms to my students. Okay, so now let's look at combinations. Okay, now I agree that combinations, they're out of the scope. Okay, in the sense of look at the complexity. You're not going to talk about factorials with a student in this manner, but you are an educator. You should know the basics of this, okay, and how to use a calculator, okay? So let's see. It does say to note, even though each card is unique, the order of the cards drawn will not matter, which means this is a basic combination, right? So the equation that they give that it means, yes, totally out of scope. But using the calculator and understanding of what's going on, definitely in the scope of what your knowledge should be. So let's look at number 4. In a game of cards, a player is given a hand with 5 cards. How many different hands are possible? Okay, so what do we need to do? Well, we know that we're talking about just regular ordinary cards, or we can make that assumption. So we have 52. Okay, press the same button as a permutation, our PRB button, but we need number 2. Okay, now how many cards are we concerned with? The 5. Okay, great. Now push enter, and that is the value that we need, which is option D. Okay, let's move on to number 5. Number 5, Isabel tossed a coin twice. Which probability tree diagram shows all the possible outcomes of the coin landing heads up or tails up? Okay, for A and D, they don't make sense. Why do they not make sense? Our word problem told us exactly what to do, heads or tails. A gives me only heads, D only tails. Now we have C and B. Let's look at C. That's great for the first toss, but for the second toss, it doesn't make sense. If I toss heads the first time, what they're saying is on the second toss, I'm only going to get heads. If I get heads once, it guarantees heads twice. That does not make sense unless you have a trick coin that has heads on both sides. But then, if that was the case, then the tails wouldn't make sense. So obviously, we're dealing with B. That makes sense. If I get tails, well, the second time I might get either heads or tails. If I got heads the first time, the second time I tossed, I could get either of them. Okay, let's look at number 6. When scientists study a population of 1,200 frogs, it is found that 12 out of every 180 frogs in the population had spots on their back. Based on the results of the study, how many frogs in the population do not have spotted backs? Okay, first we need to deal with the fact that we're given what we're not looking for, but we can get it. Let me show you very quickly. First, we're looking for an X amount of frogs out of a total population, our sample, which is 1,200 frogs. Somebody has been able to, you know, keep a record of how many frogs we have. Okay, well, that being said, now we have another proportion. Well, that's a lot of frogs to look at. So let's just go and pick out, have somebody go out and look at a total of 180. Okay, however, out of that population, we're not asking how many have spots, how many do not have spots. So that would be 180 minus the 12. Be careful with this, okay? I already know how to enter it in the calculator very accurately, but be careful when you do this because of order of operations, okay? Do not do here. First, I'm going to show you what to do, and then I'm going to tell you what to be careful with. Okay. So I'm going to set up a fraction, and I know that the first thing I need to put in as my numerator is what I have circled. Okay. And we teach this to the students generally before Christmas, and then after Christmas, they would be presented with questions like what you see here. Okay. All right. So I have 1,200, and I'm going to use parentheses and 180 minus the 12. Okay. Now I know that I must divide by what's across from the x, which is the 180. And this is giving me a great value option. Oops, let me go ahead. There we go. All right. Option B. Wonderful. Now, this is what I want you to understand and to be careful with. So, and sometimes you would actually have this wrong value on on a test. Okay, watch what I'm doing. You have 12,000. You might have been tempted to do this times 180 minus the 12. Push enter and then divide by the 180. That is incorrect. Why is it incorrect? I'm going to go and highlight right here. This. What happened is, I'll enter, see, I have it highlighted. I'm going to capture it. What happened is that your order of operations always says do your multiplication first and then subtract. Okay, so either you use parentheses or you go about it correctly. Okay, and here, I'm going to go ahead and clear that out. And you say 180 minus the 12, and then say times, okay, your 1,200, and then use that to divide by 180. But notice how many more steps it takes, and it will eat up your time. Also notice that I did not write it out. Sure, you could write it out, but you're wasting time. When you teach your students, yes, you write it out, they write it out. You are trying to grasp the best way to enter things in the calculator, and this is the best way. We go back up and capture that. And this is another thing. Always use your up and down to grab things. Okay, instead of retyping. All right, see what I did? I just avoided the order of operations situation by using parentheses. And that is often why in mathematics you see that. Okay, very simple. That's exactly why I did what I did. push enter, and there again. You see how the two values are the same. And one doesn't take quite as much time and also obeys order of operations. All right, let's move on to number 7. Number 7, you toss 3 coins during a probability experiment. The outcomes have been recorded in the table below for the first 40 trials. How many of the next 120 trials result with exactly 2 of the coins showing heads? Okay, so we want heads to equal exactly 2, and then that's out of the totals. Okay. So first, we know, we look at our table. It says exactly. We cannot deviate from that. It doesn't say at least. That excludes the first row. Obviously, the second row says tails, so can't use it. The last row is only 1. Okay, because of the wording, we must select the third row, which is 16. So we know we have 16 out of 40. They gave us our total trials. Now, trials must be set equal to whatever the total we have, whatever we're working with. Well, it says 120 trials. Okay, total. Okay, but they're asking for heads, which is a part of the total. Well, how many would that be if we had 16 happening twice? Okay, fine. Now we know exactly what to do. We don't have to worry about order of operations if we use our fraction button. So we have 16 times 120, and then that is all divided by the 40. Okay, and enter. 48 is exactly what we need. Option B. Okay, let's look at number 8. If a bag has 3 red marbles, 6 green marbles, 1 blue marble, and 4 yellow marbles, determine the probability of selecting a green marble from the bag. Well, that's just simply part over total. Well, we need green. Well, green's the part. Okay, well, we know that. But now we just add up the total. And in all reality, here's the best way to do this so you're accurate. Crazy, but it works. Okay, do your fraction. Well, I need green. Well, what's my total? Don't sit there and worry about it, trying to do it in your head. Do this 3 plus 6 plus 1 plus 4. Okay, double check that you have it right. Push enter. Okay, now that gives me a fraction. Fine, use your toggle button above your enter. And that gives me my approximation. Look down. Which one of these gives me an appropriately rounded probability? Well, here's the thing. You need to be careful. Okay, obviously A is not going to work, or C. Don't choose B. Why not? Because that would be 40%. That is not 3 over 7. Okay, so if you look, D is better. And I'm going to tell you or show you very quickly why it won't work. Remember, we had 3 out of 7. Okay, keep that, and that's the reduced amount. Okay, now I'm going to put 0.4 in my calculator. I have it entered. Now I'm going to push the toggle button. That reduces to 2 out of 5. That is not 3 out of 7. They are not the same thing. That is why you have to be careful when you round. Option D is what we need. Okay, this is the last question in this video, and I really wanted to thank people for watching, sharing, liking, and subscribing. And don't forget about going to our new website at numbersarenadical.com if you would like to purchase these items that I use, these printable items. The questions is what I'm saying. There are questions that you can print out so you can follow along in the videos, and they are very inexpensive. All right. Thank you for watching. Happy testing, everyone.